All right, welcome back to your favorite technical math class. Going to take a look at quadrilaterals and circles, perimeters, and circumferences, areas, and so on. So the perimeter is the sum of the lengths of the sides around it. Right? So for a rectangle here, the perimeter would be the L plus the L, the length plus the length plus the width plus the width. Right? In other words, L plus L would be 2L, W plus W would be 2W. So that's where our formula for the perimeter of a rectangle comes from, right? Just adding up all the sides. And that would be like, if I'm measuring it with a ruler, all the side lengths, or how much fencing I have, right? It would be like that many feet of fencing, right? Now, on the other hand, if you're trying to figure out if I'm painting this thing, how much paint do I need? That's the area, right? So the area of this is length times width. And I'm not sure why I made the longer one W and the shorter one L, but whatever. We've got the area's length times the width, right? One side length, the base times the height there. So let's go ahead and do it for a rectangle here. And let me draw a rectangle with actually a longer side L here, who's 14, and the width here, who is 9 feet, right? So what would the perimeter be? Well, it would be 14 plus the 14 on top plus the 9 plus the 9. And so that would end up being 28 plus 18, 46, and this is all in feet, right? It's just our units. Whatever our units are, in this case, they're feet. Now the area, which is how much paint would it be, the area is the length times the width. So I got 14 feet times our width here is 9 feet. So I go ahead and multiply 14 times 9, and I get 126. And feet times feet is square feet, right? Square feet. So in other words, if this was split up, you'd have that many, and I didn't draw that to scale, obviously, but you'd have 126 square feet of those coverage, right? In paint, I'd need 126 square feet to paint that green. All right, find the perimeter and area of the square shown below. Well, a square is just a special type of rectangle where all the side lengths are the same size, same length, right? And so if I'm finding our perimeter, I'm just going to add them all up. 8 plus 8 plus 8 plus 8. Looks like we got 32 feet. If I'm finding my area, it's length times width. 8 feet times 8 feet. So we got 64 square feet. That would be how much paint I would need to paint that. All right, 64 square feet. All right, let's look at some different quadrilaterals now. Parallelogram. A parallelogram is where you've got the opposite sides are parallel. So this side is parallel to that side, the left and the right, and then the top and the bottom here are parallel, if you can see that, right? Opposite sides are parallel. However, the interior angles are not 90 degrees. Like the rectangle, we had right angles, right? On all 4 angles. This one we do not. Now the height here shown, h, let me outline that in orange here. This height or altitude makes a 90-degree angle. And so the perimeter is I just add up all the side lengths. The area, I have to know that height there, and I multiply it by my base. Okay, so let's go ahead and find the perimeter of this parallelogram. So this perimeter would be 55, the top, plus the bottom, plus the left side, plus the right side. All right, so we got 55 plus 55 plus 53 plus 53, which ends up being 216 our units, which our units here are inches. All right. Now our area is the base times the height. So our base here is 55 inches. And our height here is, see how it gives us the that height there is 49 inches, so it's straight down and makes a 90-degree angle. So our height is 49 inches. And so I go ahead and I multiply 55 times 49 into my calculator. I get 2695 inches times inches, square inches. Trapezoids is where you've got one set of sides that are parallel. So if you notice on this one shown, base 1 and base 2 are parallel. See how those top and bottom there? So only one set is parallel. We still have 4 sides. A and C, they can be equal in length or they don't have to be. It doesn't matter, but they're not parallel, right? Just one set is parallel. The height, again, or the altitude does make a 90-degree angle. We need to know that height for the area formula. Let's go ahead and find the perimeter of this trapezoid here by adding up all the sides. So 14 plus the 24 plus the 42 plus the 29. I add up all these and I get 109. Let's say my units are inches, in inches. Okay. Now our area formula for a trapezoid is right there. It's a half times the height times the quantity of the sum of base 1 plus base 2. Base 1 and base 2 are our parallel side lengths. Okay. So here is my base 1, the ones that are parallel, and base 2. And my height, you can see it, they give it to us right there. That's our H22. There's our altitude, right? It makes that 90-degree angle. So we're just going to go ahead and enter those in. 1/2, our height here is 22. Our base 1, top and bottom, added up. Top plus bottom. So we got 1 times 22 is 22 over 2 times 1. 22 over 2 is 11. I got 14 plus 42. That'll give me 56. So then I got 11 times 56, which ends up being 616. And this will, again, be units squared. So in this case, it's inches. Inches would be squared. And that's the area in green, right? How much paint I would need to paint that. Well, our next shape is the triangle here. So the perimeter is, again, add up all the side lengths, right? And then the area of a triangle would be 1/2 base times height, right? And by the way, where does that formula come from? If you take like a rectangle, for example, right? Base times height, that would be the area of the whole thing, base times height. So if I just want half of it, which is that triangle right there, it'd be 1/2 base times height, right? So 1/2 base times height will give us the area of a triangle. Let's go ahead and first, though, on this one, find the perimeter. 7 plus 9 plus 4. So our perimeter here ends up being 20. Let's make this in meters this time, 20 meters. Now let's do our area. So 1/2 base times height. You see our base here is that 9, and our height is that altitude right there of 5. So we've got 1/2 base times height. Oops. Height here is 5. So we've got 1/2. 9 times 5 is 45. This is 45 over 1. So we've got our area here. 1 times 45 is 45. 2 times 1 is 2. 45 over 2, or in other words, 22.5. This would be meters squared, right? That's how much paint it would take to do that, paint that triangle. How about this one with no picture? The base of a triangle is 7 meters longer than the height. Let's go ahead and draw this. And here's our height. Here's our height. And the base is 7 meters longer. So this base right here is 7 meters longer than the height. So I'm going to call that H plus 7. If the area of the triangle is 22 square meters, what are the base and the height? So we know area is 1/2 base times height, right? And they tell us that that area is 22. And our base here is that H plus 7. and our height here is just h. Okay? So how I'm going to solve this, I'm going to end up having a quadratic. Let me get rid of the 1/2 part. So let me multiply by 2 on this side and 2 on this side. So I got 44 equals h times h plus 7. And now I'm going to go ahead and distribute that. Again, I'm solving a quadratic here. H times h is h squared. H times 7 is 7h. And I'm solving a quadratic, right? See the h squared. So I want to get one side equal to 0. So 0 equals h squared plus 7h minus 44. Now I'm just going to use the quadratic formula. If I have something in this form, I know it's usually x squared. Here I have h squared, but ax squared plus bx plus c. So my a here is 1, the number in front of h squared. My b is the 7, and my c is negative 44. I could plug it into my quadratic formula. So x equals negative b. In this case, it's h. H equals, if you remember the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. I'm not sure how you guys remembered it. That's one way to remember it, is that pop goes the weasel. All right, whenever you're solving a quadratic, get one side equals 0, identify a, b, c, and we'll throw it in. Negative, our b here is that 7, plus or minus, b is 7, b squared minus 4. Our a here is the 1. Our c is that negative 44. And this is all over 2 times a. A is 1. All right. So we got negative 7 plus or minus square root of 7 squared, I got 49. And then negative 4 times 1 is negative 4. Negative 4 times negative 44. Let me punch that in. I got 176. So plus a 176. Again, negative 4 times negative 44. So all over 2. Now I'm going to combine 49 and 176. And I get 225. Now I'm going to go ahead and punch in the square root of 225, and I'll get 15. So I have two answers. I got negative 7 plus 15 over 2, and I got negative 7 minus 15 over 2. Well, negative 7 plus 15, that would be 8 over 2, which is 4. Over here, negative 7 minus 15, that would be a negative 22 over 2. I can't have a negative 11. I can't have a negative side length, right? So I'm going to throw that answer out. So it's just the 4. So now I know this is 4 meters. My height is 4 meters, which means my base, which is 7 meters longer than that, would be 4 plus 7. 11 meters would be my base. So height of 4 meters, the base is 7, more than that, so I'd have 11. So again, use that quadratic formula, plug that in, and solve that one. All right, let's take a look at circles now. So a circle by definition is all points in a plane that are equidistant from a center, right? So if this is a distance of 5, all the points that are a distance of 5, and soon enough when I draw all of them, it's soon enough it's going to be solid, right? All points that are equidistant from the center. And the distance from the center out, of course, is your radius, right, out to a point. If you go all the way across from one side and through the center, you got your diameter, right? Diameter is double the distance of the radius. And finally, you see the circumference on the outside. It's kind of like your perimeter, except there's no side length, right? It's just the length around it. Circular, so we call this the circumference, right? The length around circumference. So we got some formulas. The circumference is 2 times pi times r, and since I know 2 times the radius is the diameter, you could also use the circumference as just pi times diameter, right? Since 2r is the diameter, and then the area of the circle is given pi r squared. So let's go ahead and find the circumference here. And the area, let's start with our circumference, 2 pi r or you could go pi times the diameter. Notice our diameter here is 8, so our radius would be half of that, 4 inches, right? So let's punch it in, 2 times pi times 4 inches, so I got 2 times 4 is 8 pi inches, and then I go ahead and I punch that in using my Desmos here. Let's pull up Desmos. I got 8, and I use that pi button right there. Enter, and I get that 25.132 and so on. So again, use that pi button. That was 25.13274.123 inches. Of course, we could round that if we wanted to. And again, note, you could have also used pi times the diameter here, since the diameter is given all the way across through the center, right? And you'd get the same thing. Same thing. All right, let's do our area now. Our area is pi times the radius squared. So pi, our radius here is 4 inches. So we got 4 inches squared, right? So 16 pi square inches. And then we punch in 16 times pi, and you get 50.26548.246 square inches on that. And that's it for quadrilaterals and circles. Hope that helps you guys get started. Have a good one.